Okay, so with today's lesson, we are continuing our study of triangles. So yesterday we talked about the angles in a triangle. Today we're going to be talking about the lengths. And what we're going to figure out is whether we can take any three lengths and make a triangle out of any three lengths that we choose, which we're going to find out might not work so well. Number 2 says if we have two side lengths of a triangle, what would be all the possible lengths that the third side could be? And we get to use manipulatives today, so that's kind of fun. So anyone who's just watching this video, unless they have Cuisinart rods sitting around their house, which most people don't get to play with the manipulatives. So, all right, so the first slide says, can you make a triangle from sides of any length? So we're going to try some different lengths. So now is when you can get your blocks out. So go ahead and get them out and arrange them the same way that I have them arranged here. All of that. Okay, so we determined that 7, 8, and 10 did make a triangle. We could make a triangle with 4, 5, and 6, but we were unsuccessful with 3, 4, 8, 4, 5, and 10. Why do you think, what happened when you tried to make a triangle with those numbers? What didn't work? Hayden?
Like, the bottom were fine, but the top sides weren't big enough.
Okay, so the top, so when you tried to make the two tops to the triangle, you set your B's down and your two tops wouldn't touch. Michael?
One for 3, 2, 3, 2 small.
Okay, so you said it a different way. You could put the two smaller ones to start a triangle, but then the bottom was too big.
That like the top was like too small. Like when we do like 4 or 5, and then we do 10, it was like that, and then like they wouldn't even touch it all.
They wouldn't touch it all. Okay, good. Let's look at. There's actually a rule about this. It's called the triangle inequality theorem, and you've just discovered it. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we have 3 sides of a triangle, if we add up the two smaller sides, it has to be bigger than the third side. Otherwise, we can't make a triangle because they won't be able to touch at the top. So this kind of shows you an example of that. This triangle can't quite touch at the top, no matter what we do to it. This triangle actually has equal segments. If I laid this segment down on top of the triangle, it would go to here. And the yellow one would go to here. They would touch each other if it was flat, but as soon as we start to open up those segments, they don't touch anymore. So this is an example. If they're equal, it won't make a triangle either. It has to be bigger. When we add the two smaller sides, it has to be bigger than the third side. So we don't have to use blocks every time we do this. Letter A says we're going to do 1, 2, and 3. So my two smaller sides are 1 and 2. If I add 1 plus 2, what do I get? 3. Is 3 bigger than 3?
No.
No. So this would not make a triangle. So we can say no. What about B? Let's see. My two smallest numbers are 2 and 5. If I add 5 plus 2, what do I get? 7. Is that bigger than 6?
Yes.
So that will make a triangle. Okay, letter C. Let's see, I'm going to call in some of you now to give me some answers. Savannah, what are my two smallest numbers?
5 and 4.
Okay, if I add them together, what do I get? 9. Is that bigger than 7?
Yes.
So can I make a triangle? Yes. Okay, letter D. Jordan, what are my two smallest numbers?
3, 2,
Okay, what do we get when we add 3 plus 2?
5,
Is that bigger than 6?
no,
So can we make a triangle?
no.
Okay, letter E. Paul, what are my two smallest sides?
10 and 10.
10 and 10. They're all the same, so we can say 10 and 10. What's 10 plus 10? And is that bigger than 10?
Yeah,
So could we make a triangle?
possibly.
If when we add them up, if it's bigger than the third side, we can. So 10 plus 10 is 20. 20 is bigger than 10. So yes, we could make a triangle. What kind of triangle would this be? We could give this a name using its sides. David? It would be an equilateral triangle. So anytime you have three sides that are all the same, you're always going to be able to make a triangle. All right, letter F. Laura, what are my two smallest numbers?
13, 12.
13 and 12. What is 13 plus 12? 25. Is 25 bigger than 26?
No.
So can you make a triangle? No.
But it's just one less.
It doesn't matter. Even if it's the same, you still can't make a triangle. It has to be bigger. Okay. Now we're going to actually use the blocks a little bit for this. I want us to take blocks 4 and 5. So let's look back at the picture to see what color those are. 4 and 5 are purple or pink and yellow. So get those two blocks, and I want you to pick a block to make the third side. There's more than one block that's going to make the third side, and we're going to talk about the answers that you get. So go ahead and do that, and then we'll talk about it. So these are the lengths we came up with that worked to make the third side of the triangle. So when we tried 1 did not work. Let's take a look at why. If we have 1, 4, and 5, what's 4 plus 1? 5. Is that greater than 5? No, it doesn't work if they're the same. We got it to work for 2, 3, 4, 5, 6, 7, and 8, but it did not work for 9. Let's look at why. 4, 5, 9. What's 4 plus 5?
9.
Is that bigger than 9?
No.
No, it doesn't work if they're equal. If they're equal, they can line up, the two top sides can line up against the bottom side, but as soon as we start to open them up, they split apart. Now, there's a better way than using blocks every time to figure this out. What we're going to do is we're going to list a range of sides, and we're going to do that. This is very easy. We subtract to find the smallest side that would be equal. So 5 minus 4 is 1. 1 didn't work. The other side of our triangle has to be bigger than 1. Remember these symbols? We haven't talked about inequalities very much this year, but this is a less than sign. 1 is less than S, the third side, which means the third side has to be greater than 1. And the third side has to be less than, when we add these together, we get 9. So it has to be in between 1 and 9, but it can't be 1 and it can't be 9. So it could be a decimal number too. It could be something like 1.3. If we had a block that was 1.3 centimeters long, that would work. Okay, let's look at letter B. Let's do this way. So 6 minus 4 is 2, and 6 plus 4 is 10. So the third side of this triangle has to be bigger than 2, and it has to be less than 10. It can't be 2, it can't be 10, it can be any number in between 2 and 10.
What is
David?
5.
You're suggesting a side? 5 would work? Someone tell me another side that would work for this triangle. Really?
5.
Any number in between 2 and 10 would work. She had already said 5. Let's pick something different. 4 would work. Savannah?
3.
3?
6?
6. Someone tell me a decimal that would work. Savannah? 2 point something? Yeah, because that's bigger than 2. 2.3 would work. Good. All right, let's take a look at C. Let's find, we're going to have the S in the middle. S has to be less than something and greater than something. So you can set this up right away. What does S have to be greater than? What's 8 minus 1? 7. So S has to be greater than 7. The third side has to be greater than 7. What does it have to be less than? 9. So let's talk about some sides that we could have for this triangle. What would be some lengths? Haley?
8.6.
8.6. There we go. That's one. What's another one we should have? Another length for the third side. Sean, what's another length? Any number between 7 and 9 will work.
6?
Is 6 bigger than 7? Any number, look at the number line. It has to be between 7 and 9. 8, Haley said 8.6. Hayden? 7.9 would work. Good. 8.5 would work. Any number in between 7 and 9 would work to be the third side. All right, let's do letter D. S has to be bigger than something, and it has to be less than something. What does the third side have to be bigger than? Caitlin? Remember how to find that? Subtract. It's 5 minus 3. 2. So it has to be bigger than 2. Michaela, what does it have to be less than? 8. Good. We add 3 plus 5 is 8. So the third side has to be between 2 and 8. Hayden, tell me what a possible length of the third side would be. Did you say 3? Yes. Yeah, 3 would be 1. Jaden, tell me another length of the third side for this triangle. 4 would work. And David, give me one more. 5.5. Thanks for using the decimal. All right, let's go on. There's another letter D here. That's my silly mistake. All right, so the third side of this triangle has to be between what two numbers? Madison, what does it have to be bigger than? How do we find the number that it has to be greater than? Someone want to tell Madison what we need to do? Savannah?
Greater?
Yeah, how do we find the smaller number? Subtract. So we have to subtract 8 minus 4. What do we get when we subtract 8 minus 4? 4. So the third side has to be bigger than 4. Haley, what does it have to be less than? 12. Michael, tell me what a possible side length could be. 3? Is 3 in between 4 and 12 on the number line? Look up at the number line. Nope.
5.5.
6, okay, 6 would work. Sean, tell me another one. 5.5. Braylee, tell me one more. Any number between 4 and 12. 10 would work. All right, letter E. The third side has to be between what two numbers? Brandon, what does it have to be greater than?
12. Greater than 5.
No. How do we get this number on the left? Michaela, can you tell them how you get it, but don't do it?
Subtract.
Subtract. When we subtract these two sides, we get the number that it has to be greater than. So what's 12 minus 5? 7. So the third side has to be greater than 7, and Judy, it has to be less than what?
I can't calculate them.
What's 5 plus 2?
5. 17.
It's 17, there you go. So the third side has to be between 7 and 17. RJ, tell me what a possible side length could be for the third side of this triangle. No. Any number between 7 and 17 will work. So just pick one. Any number that fits on the number line in between 7 and 17. 8 would work. All right, Savannah, letter F. What does F, the third side, have to be greater than? It would be 0. It has to be greater than 0. So it can be anything, as long as it's bigger than 0, and anything that you have has to be bigger than 0. So it could be like 0.000005, and you could make a really skinny triangle. What does it have to be less than, Jordan? 8. Give me a possible length for that third side, Paul. What?
4.3.
4 point, what did you say? Yeah, that would work. Good. Okay, last one, letter G. Laura, what does the third side have to be greater than? Greater than what? No, we're on this one. We need to find what this lower number is. Can someone help Laura to tell her how we find the low number? Caitlin. We subtract these numbers to find out what the third side, yep, has to be greater than 6. And what does it have to be less than? Caitlin.
6.
We have to add these to find what it has to be less than. What's 9 plus 3? 12. So it has to be between 6 and 12. Michaela, give me a possible side length. 8 would work. Good. All right. Yes. What's your question?
Can you write it backwards, like 12 that way as same way 6, like completely the opposite
Yeah.
way?
So you're saying, could you write it this way? As long as your signs are going the other way.
Okay.
But it's better to just keep it the same way. Yes.
How are we gonna do a bit more
Uh-huh.
math? Is it gonna be like what other years?
Yeah, it'll show up on the review too. Sean? Yes, we're done with the lesson. All right.